Good day everyone. We are making this mini video tutorial to comply the final requirement of our subject in IT 604. Our topic is all about transmission media and communication cable. Communication networks employ a variety of transmission media ranging from copper wires to satellite channels to transport the user's information. Transmission media is a physical path for the communication signal. It means through which the data is transformed from one place to another. And it is divided into two major categories, the unbounded and bounded media. The bounded media which may constrain and guide the communication signal, while the unbounded which only permits signal to be transmitted but cannot guide them. So, furthermore about the bounded and unbounded, I have my group mates to tackle about it.
Hi guys! According to Jollibee a while ago, there are two categories of transmission media used in computer communication, and these are bounded media and unbounded media. And I'm going to tackle about bounded media. Bounded media are the physical links through which signals are confined to narrow paths. This is also called guided media. It is made of a conductor which is usually made of copper and is jacketed with material. Bonded media provides high speed and is very secure. Its drawback is that it cannot be used for distance communication because of the physical items that it requires to run. Bonded media has three types. These are twisted pair cables, fiber optics cables, and coaxial cables. Coaxial cable is very common and widely used communication media. For example, in TV wire is usually coaxial cable. Coaxial cable gets its name because it contains two conductors that are parallel to each other. The center conductor in the cable is usually copper. The copper can be either a solid wire or standard material, and it has advantages and disadvantages. The advantages of coaxial cable, it is inexpensive, easy to wire, easy to expand, moderate level of EM immunity. And the disadvantages of coaxial cable, it is single cable failure can take down an entire network. Then, let's go to twisted pair cables. Twisted pair cables, the most popular network cablings is twisted pair. It is lightweight, easy to install, inexpensive, and supports many different types of networks. There are two types of twisted pairs cabling. First, the unshielded twisted pair or the UTP. Second is the shielded twisted pair or the STP. Unshielded twisted pair or UTP is more common. It can be either voice grade or data grade depending on the condition. And the disadvantages of UTP, it is easy installation, capable of high speed for LAN, low cost, and the disadvantages is short distance due to attenuation. Then the second one is the shielded twisted pair or the STP. It is similar to UTP but has a mesh shielding that protects it from EMI, which allows for higher transmission rate. And STP has advantages and disadvantages. And the disadvantages, shielded faster than UTP and coaxial. Then disadvantages, more expensive than UTP and coaxial. More difficult installation, high attenuation rate, fiber optics. And let's go to fiber optics. Fiber optics cable uses electrical signals to transmitted data. It uses light in fiber optic cable. Light only moves in one direction for two-way communication to take place. A second connection must be made between the two devices. It is actually two strands of cable. Each strand is responsible for one direction of communication. And the advantages of fiber optics. It is fast and low attenuation. No EMI interference. And the disadvantages, very costly, hard to install. And all in all, fiber optics is the most reliable among the three because it is the fastest among the three. And that's all. And the second category, which is the unbounded media, will be discussed by Evelyn.
The second category of transmission media is unbounded media. Unbounded media or wireless media doesn't use any physical connectors between the two devices communicating. Usually, the transmission is sent through the atmosphere, but sometimes it can be just across the road. Wireless media is used when a physical obstruction or distance blocks are used with a normal cable media. There are three types of wireless media: the radio wave, the microwave, and infrared wave. The radio wave, it has frequency between 10 kHz to 1 GHz. Radio wave has the following types: the short wave, the very high frequency, and the ultra high frequency. The short wave. There are different types of antennas used for radio wave and can be divided into following categories: low power single frequency and high power single frequency. The low power or single frequency is the normal operating ranges on these devices are 20 to 25 meters. And the high power single frequency, this is similar to low power single frequency. These devices can communicate over greater distances. Microwave. Microwave travels at high frequency than radio wave and provides throughput as a wireless network media. Microwave transmission requires the sender to be inside of the receiver. There are two types of microwave: the terrestrial microwave and satellite microwave. Terrestrial microwaves are used to transmit wireless signals across a few miles. Terrestrial system requires that various parabolic antennas can be pointed to each other. These systems operate in a low gigahertz range. The satellite microwave transmission is used to transmit signals throughout the world. Infrared wave. Infrared frequencies are just below visible light. These high frequencies allow high-speed data transmission. This technology is similar to the use of remote control for a TV. These transmissions fall into two categories. First is point-to-point, and the second is broadcast. In point-to-point, infrared transmission signal directly between two systems. Many laptop systems use point-to-point transmission. In broadcast, this infrared transmission use straight signal, one broadcast in all directions. Aside from bounded and unbounded media, we have related topics regarding with the transmission media and communication cable. One of them is the intermediate distribution frame, or the IDF. IDF is a freestanding or wall-mounted rack for wiring or cable from a main distribution frame, or MDF. It interconnects and manages the telecommunications wiring between an MDF and workstation devices. Cables entering a building run through a centralized MDF. Then each individual NDF, IDF, and then onto specific workstation. IDFs are used for wide area network, or WAN, LANs or the LAN, local area network, customer or end users, buildings and telephone exchange and central offices. Then we have the other one, the main distribution frame or the MDF. It is the signal distribution frame or a cable rack used in a telephone to interconnect and manage telecommunication wiring between itself and any number of intermediate distribution frames and cabling from the telephone network in it that it supports. The MDF connects equipment inside the telecommunications facility to cables and subscribers' carrier equipment. Every cable that supplies services to user telephone lines ends up at an MDF and is distributed through MDF to equipment within local exchanges. Unlike an IDF, which connects internal lines to MDF, the MDF connects private or public lines coming into a building with the internal network. For example, an enterprise that encompasses a building with several floors may have one centralized MDF on the first floor and then one IDF on each of the floors that is connected to the MDF. The MDF is the main computer room for servers, hubs, routers, DSLs, and others, while the IDF is the remote room or closet connected to the MDF by the other optic cable. You can expect that you can find the IDF in hubs and patch panels.
We would like to acknowledge our parents for supporting us and to First John for the accommodation and most especially to the Almighty God for guiding us.
I hope you learned something from our video.
Thank you for watching.
Bye!